Okay, so now let's talk about what elements is life composed of. But before we do that, let's go back to a previous lesson when we talked about planetary geology, and we started off with what elements make up outer space, then what elements make up the Earth as a whole, and then what elements make up the crust of the Earth. And so you notice that in the crust of the Earth, oxygen is the most important element, followed by silicon. And then when these two would join together, they would form the backbone of the silicate minerals then that would make up the majority of the rocks found in the crust of the Earth. And then you've got aluminum, iron, and nickel. Now with organic materials, again, oxygen is the most important element, followed by carbon, and then followed by hydrogen and nitrogen, which in geological terms, hydrogen and nitrogen are going to be gases and they tend to escape. So hydrogen and nitrogen are not normally found in the minerals that make up the Earth. But calcium, though, is found geologically. So calcium makes up calcium carbonate, which is a calcite, which makes up the rock limestone. Whereas with humans, calcium can be found in our bones. Plays a very similar role. And also, iron is inside of your body, in your blood, in your hemoglobin. So that there are certain elements that are going to be found both in the crust of the Earth and in organic materials, but there are going to be certain kinds of materials that are almost exclusively going to be found in organic materials. And so what we want to do is make a comparison of silicon versus carbon. So if we go back to the periodic table and we look for silicon and carbon, we notice that they are both in column 4 of the periodic table. So what does that mean? It means that they have 4 valence electrons, both carbon and silicon. 4 outer electrons. Now we said that the valence electrons are the ones that participate in chemical reactions. So whether we're talking about silicon or carbon, they're going to have 4 hooks, 4 things then that can attach to other things. And so in the case of silicon, it attaches to oxygen, so that a silica tetrahedron is going to have oxygens on the ends of all of these things, and then these in turn can connect to other silica tetrahedrons, and we said that they could make chains, and they could make sheets, and they could make 3-dimensional structures, because silicon forms the backbone of geological processes. Carbon also is going to have 4 valence electrons. It's going to have 4 hooks on it, and so it in turn can connect to other things. But carbon is going to be more versatile than what silicon is going to be. And so one of the things that carbon can do is it could attach to another carbon, so it can make chains. You can see sometimes another carbon can be attached to the chain so that the chain can have branches on it. Sometimes the chain can be wrapped around, and so it can make a circle of these carbons. Another thing that they can do is carbons can attach to have a double bond, so that if you have another carbon over here that also is going to have 4 valence electrons, then 2 of these things can hook together and you can have a double bond. And you can even have a triple bond with carbons. So carbons are very, very versatile. Also, I wanted you to see that boron and nickel, nitrogen, so boron, nitrogen, and silicon and phosphorus can all make multiple attachments, but their chemical bonds are not as stable, so that carbon makes the best building block for life. All right, let's take a break. When we come back, we're going to talk about 5 key organic molecules.